right, so this problem is obviously very confusing to most people. It's a pretty weird shape and it's not easy to work with, but they've told us a couple things that are useful. And they've told us that all of these sides out here are equal to each other. That side and that side, this side and this side, within each of their own triangles, they're equal to each other, which means this angle and this angle are equal to each other. And if these angles are equal to each other, then that means that this angle and this angle are equal to each other, because they have to add up to 180 since they're next to each other and they're created by two lines that are intersecting. So all the way around this angle from here to here has to add up to 180. And because of this, we know also from here to here has to add up to 180, because that's half a circle's worth of angle as well. And if that's true, then this angle in here must be equal to this angle here, because they are complementing this same angle. If you call this angle x, then x plus the red angle, we'll call that r, equals 180. And if this plus r also equals 180, we'll call it y, then y and x must be equal to each other. So that's the thought process, which means every single one of these angles out here is going to be the same thing. And if that's true, then all of those interior angles must also be the same thing as well. And this makes life a lot easier. So if these angles all have to be the exact same, and there's 9 of them, and we have a 9-sided shape, well, there's a formula that tells us the sum of the interior angles of a 9-sided shape. And that is n, the number of sides, minus 2 times 180 gives the sum of interior angles. So this formula means that 9 minus 2, which is 7, times 180 gives us the sum of interior angles. And if every one of these interior angles in red is equal to each other, that means that if I divide 1260 by 9, I will get the value of a single angle. And when I do that, and this is, I just want to outline this because this is the way I think of doing that division. Instead of worrying about 1260 divided by, or sorry, that's square root symbol, divided by 9. Instead of worrying about doing it this way, which you absolutely can, I like to think of it as, how do I add up in increments of 9 to get to 1260? And it's 900 is like the big jump that I can make to get close to it. And that's 9 times 100. So I choose an easy multiple of 9 that's really large to get me close. And then I need another 360. If I do 1260 minus 900, there's 360 left. That's 36 times 10. 36 is 9 times 4. So this would be 9 times 40. And that means I have 140 nines, which means 1260 divided by 9 would give you 140. So this is how I like to do division. I think it's simpler. It's more intuitive. So you try to add up to the total of this number in increments of 9 using multiples that you know. Okay, so anyways, we know that each of these angles inside is 140. And if these angles add up to a total of 180, then each of these angles inside are 40. And that would leave exactly 100 degrees left within these little triangles. If we have two angles that are 40, they add up to 80. And out of the 180, we have 100 left for this angle out here, which means that A would be equal to 100. And that gives us answer choice A. So this is pretty tough to see. I mean, it's pretty challenging, even like for someone who's really good at geometry, to recognize what's going on here. Honestly, when I look at this, what tipped me off on how to approach this problem is I looked at the angles on the inside and I thought they all looked pretty identical, which is really weird because the shape is not very perfect. It's not like all the sides are equal or anything like that. So I was kind of looking for a clue, and I saw all those angles look relatively similar. And I wondered, can I pretend that this is a perfect shape? Could I pretend that all those angles were similar? And then I thought about it. And I was like, actually, I don't even have to pretend, they actually are similar. So if you look for a clue like that, if you pretend in geometry, or not pretend, but just look visually in geometry instead of trying to do like really hard math, sometimes you can pick up on little things that'll help you out. And definitely you can't do it. You can't do this problem without having this concept down, the n minus 2 times 180. But But I think like the big non-starter for most people is that initial point of not knowing what to do with these angles. And the fact that they are all the same is hugely helpful. And that's how we're able to solve with answer choice A.